This is our next Fast 5 or SAT prep, and we're going to discuss measures of central tendency, mostly mean, median, and mode. So let's go back to those concepts of mean, median, and mode. Remember that mean means the average of the numbers, so you add them all up and you divide by how many numbers there are. Median is the middle. So typically what you guys did was you lined up all the data values in order, and then you started like hacking away from beginning to end until you found the middle number. Now if there were two numbers in the middle, then you found the middle of the middle. So you added them up and divided by 2. And then mode was the most frequently occurring data value. And there can be more than one mode in a data set, so keep that in mind. Range is not a measure of central tendency, it's a measure of the variability of your data. So range is just the difference between the minimum and the maximum data value in your list. There's another one called standard deviation that, unless you've had a little bit of stats, you probably have no idea what that means. It does show up on the SAT once in a while, but you know, it's kind of a big topic to gloss over in 30 seconds. So this question is, all the data is given to you in what's called a frequency table. So they have 20 students that are in a college class, and they tallied up all their ages. So this is what the SAT question looks like. I went ahead and listed out all the data the long way, because a frequency table is just a shorthand way of saying that I have 6 18-year-olds, 5 19-year-olds, and so on and so on. So they want me to compare the mean, median, and mode, and a frequency table is awesome for shortening your data look, but also for looking at the mode. I can tell the mode is the most frequently occurring data value, so that would be 18 years old, or mostly 18-year-olds in this class. And then the mean, I'm going to go ahead and calculate that on my calculator, or you would. So what you'd have to do, instead of doing 18 plus 18 plus 18 plus 18 and so on, I would just do 18 times 6 plus 19 times 5 plus and so on and so on and so on down the list. And that's going to give you a total of 400. But then remember, you're supposed to divide by how many people were in the data set. So in this case, it was 20 people. So 400 divided by 20 gives us a mean value of 20. And then the median, there's a formula for figuring out which position in the data is the middle. So if there's 20 people, the middle is technically 10.5, the 10.5 position. So it's between the 10th and 11th data number. So 11 would be at the end of the 19s. So that's this right here is 11. So here's 10 and here's 11. So right in the middle of 19 and 19 would be 19. So when I'm going to compare smallest to biggest, the mode is the smallest, followed by the median, followed by the mean. So our answer choice would have been A. This question, these are called weighted averages, kind of. They actually give you the mean or the average, and then you got to kind of go backwards and figure out some part of the data. So the mean score of 8 players was 14.5 points for this game. So what that means is once you totaled up everybody's points, and then you divided by 8, you got an answer of 14.5. So if I think about how I can manipulate this equation, I can multiply by 8 to knock out these. And I should have done this already. But 14.5 times 8 is 116 points. So all of these 8 players together scored 116 points. I'm going to keep that clue for a moment. Let's keep reading. Then it says, if you take out the highest scoring individual, and you just leave these 7 players, their average comes down to 12 points. So all these dudes, or dudettes, divided by 7 gives you an average of 12. So multiplying both sides by 7 gives me, 84. So the sum of the other players is 84 points, which means the difference between these two sums is how much that highest scoring person actually scored. So 116 minus 84 gives me 32. Should totally check that on my calculator, but I think it's 32. All right, we're at 4 minutes still. Let's see what we can do here. Determining the mean number of children per household. Tabitha surveyed 20 families. For the 20 families, the mean number of children was 2.4. Which of the following statements is true? So the mean number of children per household in the community is 2.4. The determination about the mean number of children in the community should not be made because the sample size is too small. The sampling method is flawed because it may produce a biased estimate of the mean number of children per household in the community. Yes, and the sampling method is not flawed. So if you read very carefully, this is clearly a flawed sampling method. She surveyed people at a playground. Like, generally speaking, adults don't wander around playgrounds unless they actually have children, so she has a bad sample set. Some good vocab for you. Good luck.